Hi, welcome back to the Laurelton Hall AP Environmental Science video series featuring water pollution. So far we've looked at two primary pollutants, nitrogen and phosphorus, that cause indirect harm by over-fertilizing water systems, but many other inorganic pollutants can cause direct harm to humans and other organisms. For example, lead is a heavy metal that poses a serious health risk. Lead is not normally found in our drinking water, but contaminates water as it passes through lead pipes in older homes. Exposure to lead can cause damage to the brain, nervous system, and kidneys. Developing fetuses and infants are most susceptible to lead poisoning. Thankfully, risk of lead exposure has decreased under federal construction guidelines and with improved water filtration systems, so it is much less worrisome today than it has been in the past. Unlike lead, arsenic is naturally occurring in our water supplies. It dissolves into groundwater, leading to high concentrations of arsenic in some areas. Unfortunately, human activities such as mining and wood preservation can increase the amounts of dissolved arsenic in our water supplies. In areas like the Midwest and Western United States, where arsenic levels are high, there's a correspondingly high incidence of cancers of the skin, lungs, kidney, and bladder. Fortunately, arsenic can be removed from water supplies through fine membrane filtration, distillation, and reverse osmosis. The EPA has set the safe limit for U.S. drinking water at 10 micrograms of arsenic per liter of water. The problem, however, is not limited to the United States. Officials looking for less polluted sources of water in Bangladesh accessed deep underground aquifers, which proved to be less polluted than the surface waters, except that they were much higher in arsenic concentrations. Currently, 140 million people in Bangladesh consume drinking water with unsafe arsenic levels. Mercury is another naturally occurring heavy metal found in increasing concentrations in water due to human activity. Mercury is released by activities such as burning coal, burning garbage, disposal of medical waste and dental supplies, and, surprisingly, the manufacturing of cement. Mercury emitted by human activity eventually finds its way into surface water supplies. While inorganic mercury is not particularly harmful, it's often converted by aquatic bacteria into methylmercury, which is highly toxic. Mercury poisoning occurs mainly through the eating of fish and shellfish and results in Mad Hatter syndrome. Remember the Mad Hatter in Alice in Wonderland? He was suffering from mercury toxicity. His exposure was through the millinery or hat-making industry. Mercury was used to treat and preserve felt. Anyway, regardless of how mercury poisoning occurs, it results in impairment of coordination and the senses of touch, taste, and sight due to damages done to the central nervous system. Mercury also bioaccumulates, so it's more prevalent in organisms the higher up the food chain you go, such as tuna or people. To reduce the likelihood of mercury contamination in people, the EPA has mandated that cement producers reduce mercury emissions by 81%, and they have also established safe consumption levels of products such as tuna. The EPA is also working with other governments around the world to reduce global mercury production. Another side effect of burning coal is the formation of acid precipitation. Burning coal also releases sulfur dioxide and nitrogen dioxides into the air. These chemicals are converted into sulfuric acid and nitric acid in the atmosphere and eventually fall to the earth as acid deposition. Acid deposition can be wet in the form of rain or snow, or dry. It can actually come to earth in a gaseous state. Acid deposition can reduce the pH of surface waters to less than 5. This is lethal to many aquatic organisms. To combat this issue, many coal-burning plants have installed scrubbers. These are limestone mixtures which neutralize the acidic gases. Lower pH levels can also result from abandoned flooded mines. Pyrite in these mines breaks down, producing iron and hydrogen ions. Chemical reactions then produce low pH water, which in turn dissolves harmful heavy metals such as zinc, copper, aluminum, and manganese. In addition to naturally occurring pollutants, we have to worry about the synthetic pollutants as well. These pollutants can enter waterways via industrial point sources of manufacture or via non-point sources when they're applied. Common synthetic pollutants include pesticides, pharmaceuticals, military compounds, and industrial compounds. As we saw in an earlier chapter, pesticides play an important role in crop production. Unfortunately, pesticides are not target-specific and often prove lethal to non-target, unrelated species. Another concern regarding pesticides is that they tend to bioaccumulate. The most widely recognized case of pesticide bioaccumulation is DDT. DDT was designed to target the nervous systems of insects, but turned out to cause reproductive damage in top predators such as osprey and eagles due to its accumulation up the food chain. In addition to their active ingredients, pesticides also contain inert ingredients designed to help the pesticide work more efficiently. These inert ingredients are not required to be tested for safety, and so their effects are not always known before the pesticide comes to market. Not sure who thought that was a great idea, but the highly popular herbicide Roundup has proven deadly to amphibians due to its inert ingredient, which causes the gills of tadpoles to burst. The upside of such cases is that the U.S. and European Union are now considering laws to make the testing of inert ingredients for potential harmful effects mandatory. So these substances would become tested despite industry protests. Pharmaceutical contamination is second only to pesticide contamination in our waters. Luckily, most of these contaminants occur in very low doses that do not seem to pose a threat to our ecosystems. The exception to this is hormones or hormone suppressants. As we saw with Tyrone Hayes' tadpoles, low concentrations of these drugs can feminize male frogs. Fish, reptiles, and some mammal species even have also exhibited this imposexing or the imposing of one gender on another. Although military and industrial pollutants make up only a small percentage of water pollutants, they do have a tremendous impact. For example, perchlorates are a byproduct of military rocket manufacturing. These chemicals can leach from contaminated soil into groundwater. If humans then drink this contaminated groundwater, it can lead to impaired thyroid functioning and the reduction of hormone production. Perhaps the most damaging of industrial pollutants are PCBs, or polychlorinated biphenyls. These chemicals were used in manufacturing plastics and in insulating electrical transformers. Since this chemical class proved to be carcinogenic, production stopped in the United States in 1979. However, the compounds continue to persist in the environment. A related class of compounds, PBDEs, are turning up in very unexpected places, such as in fish, aquatic birds, and even in human breast milk. Exposure to PBDEs can lead to brain damage. Because of this, the European Union, California, and Washington State have banned their use. And of course, no look at water pollution would be complete without looking at oil. Petroleum products are highly toxic to aquatic life and are a persistent problem in the aquatic environment. Sources of oil contamination include drilling platforms, spills from tankers, and natural oil seeps. Although it is virtually impossible to completely negate the impacts of oil contamination, we have devised several remediation strategies. These strategies include hand cleaning oil off of affected marine mammals and birds, containing and vacuuming up surface spills, applying chemical dispersants that help break up the oil, and even using genetically modified bacteria to consume the oil. So we've come a long way in addressing our water pollution issues. In the next movie in the series on water pollution, we will look at less familiar sources of pollutants.